everyone. My name is Ali Kazemian from Louisiana State University. This is my first time attending ISARC conference. I'm very excited to be here with you. Um, I'm here to talk about an ongoing study on space construction and the kind of workforce training programs which are needed to enable space construction in the near future. So probably you all know about the NASA's um, Artemis program to return humans to the moon after more than 50 years. This time to stay for a long time in order to be able to do all kinds of research and learn about the moon and the universe and the resources that the moon has to offer us. And then that will also allow us to prepare for a much more challenging and exciting journey to Mars, which is even more interesting because it is one of the only other places in the solar system where life may have existed in the past. And to make this happen, one of the basic needs for survival, just like on Earth, will be housing and shelters, especially considering the unique environment of the moon. And to enable, a long-term stay, we'll definitely need launch and landing pads, habitats and research labs, radiation shielding and protective structures to protect our expensive assets on the moon, and of course, infrastructure to generate power and to distribute power on the surface of the moon. And also, we know that to build these kind of structures, we will need a lot of help from robots and machines to facilitate the construction process, to do the hard work. And based on that, we know that the role of the humans and the workforce which will be involved in the construction will be very different than the conventional construction processes that we know on Earth. With this short background, colleagues and I basically started a planning project with support from National Science Foundation. This is a short one-year planning project in which we are trying to better understand the nature of extraterrestrial construction and the skill sets and the roles of the human workers who will be involved in planetary construction. And to achieve that, the first phase of the project involved organizing and designing a two-day expert meeting. We followed several criteria which are listed here in our search of experts who are already involved in planning for space construction and implementation of the actual construction technologies which we will need for lunar construction. Here is a table which shows you the demographic of these 26 experts that we managed to gather with very diverse backgrounds, from NASA, from construction tech companies, education experts, and of course, universities with expertise in areas related to the main themes of our workshop, which was future work, the enabling technologies for construction on the moon, future workers, of course, the workforce aspect, and the technology, which is actually all about the technologies which can help us with training the workforce. So we are not talking about construction technology, the third core aspect. And then we basically design different types of sessions, as you can see, to encourage the participants to share ideas and to have discussions to be able to collect valuable feedback and refine ideas during the workshop. And I have very limited time here, so I'm just going to quickly go over some of the highlights and findings of this two-day workshop, what we learned from these experts. The first, one of the points which was repeated again and again was the unique aspects and characteristics of those kind of sites on the moon which we will build on. Partial gravity on the moon is something that we have to consider, abrasive dust, extreme temperature swings, and micrometeorite impact, radiation. All of these environmental factors need to be considered when designing machinery and robotic systems for building structures on the moon and during the construction processes on the moon. The second point which I want to highlight here is in situ resource utilization. NASA calls it ISRU. We kind of have no choice but to use the materials which are already available on the surface of the moon and Mars for construction. based on an estimate that our NASA colleagues gave us, basically shipping only 1 kilogram of materials from the Earth to the surface of the Moon, which is very close compared to Mars to Earth, costs around $1.2 million, which is super expensive. So you can imagine there is no way we can ship construction materials from Earth to build the structures on the Moon. We have to use the materials which are already available. And then we also have to, in our planning, for construction on the Moon, we have to consider the fact that there will be diverse teams, from different countries with different cultures, with different terminologies that they will be using, even different units, and how to basically create a consistent, terminology and system to work with. And there are lessons to be learned from other areas. In aerospace in 1999, NASA basically lost a very expensive spacecraft because of a simple mistake in converting a unit from English to metric. So these are things that needs to be considered in the planning phase to be able to basically successfully build infrastructure in space. The second theme, which is about workforce, was mentioned by our experts, was related to the situational awareness as a very important feature that needs to be considered. And that, again, we can also learn from other areas. For example, in NASA training programs, there are some specific, programs dedicated to train the astronauts to be able to focus on a specific task, but also be able to monitor the site for hazards and unexpected, events that could happen. And this is very important because of the high level of uncertainty on the surface of the Moon and Mars. And also other parameters, even the fact that all of these astronauts are wearing spacesuits and the kind of motion limitations, maybe the limited field of view, and the impact of the environmental factors on these, astronauts and human workers, and how it impacts the performance and the psychology of these astronauts and workers is really something that needs to be studied beforehand to be able to give us the necessary information. And then the last and third theme, which was focused on the training aspect and the kind of technologies which are needed. Of course, the ideal scenario is to practice in the actual environment, in the real life scenario, but we don't have access to that yet. So, I mean, all we have at this point is really the orbital space stations, which don't allow us, do any kind of larger scale testing. So the best we can do, the best option seems to be simulations and virtual environments, which was suggested again almost unanimously by all of our experts in the workshop. Use of mixed reality, use of AI to generate some scenarios which might not come to mind in the beginning, but AI can generate those scenarios, and then we can test those as emergencies, to train basically the astronauts and the human workers who will be helping with the construction processes. And also the fact the human factors is another thing which needs to be considered, other than the task performance metrics, which are commonly the main, consideration. Human factors like even emotions is something that need to be considered and embedded into the training program to better understand the behavior and the performance of these human workers who will be involved in space construction. So that was, again, a very quick review of the highlights and the findings of this two-day workshop that we organized, and some of the common themes and ideas that shared by our experts. But also, before I finish, this is the last slide. I just want to also highlight the other research that we are doing in collaboration with NASA Marshall, which is closely related to the first core area that I mentioned, future construction. So we are focused on the robotic construction 3D printing technologies, which use the materials which are already available on the Moon and Mars. So these materials that you see here, there's no water inside. It's a waterless using lunar and Martian regolith simulant and sulfur, for example, as the binder. And we have had a lot of results and publications, which I can share with you in another occasion, and also to improve the reliability and robustness of these technologies by inline monitoring and basically making the robotic construction process more intelligent. So at least we can minimize the need for human workers for continuous supervision during the process. With that, I want to thank you for your time, and I'll be happy to take your questions later on. Thank you.